Hello and welcome to Inside Exercise. I'm Emeritus Professor Glenn McConell from Victoria University in Australia. Today I'm bringing to you Professor Jonathan Little from the University of British Columbia in Kelowna, Canada. He's an expert on exercise, type 2 diabetes, metabolism and nutrition. And today we talked about his work and his understanding around the areas of keto diets and ketone supplements. So it's quite a polarizing sort of topic where some people are just totally into keto diets and don't think there's much place for carbohydrate, ingestion during exercise, for example, and other people have sort of gone the other way. What we'll see is it's quite nuanced. So it makes a big difference if you want to have a keto diet, for example, if you're overweight or have type 2 diabetes versus if you're an endurance athlete. And again, it will depend on the type of exercise you're doing. So if it's high intensity, short duration exercise or very prolonged exercise, and whether you're like a very well-trained person, an active person, or an elite athlete can all make a bit of a difference there. So we discussed this at length. We also discussed ketone supplements. So this, therefore, is not so much being on a diet, for a prolonged period of time to try and induce ketosis, etc. This is actually ingesting a ketone supplement just before exercise and then seeing if that affects metabolism and performance. We also talked about the effect of ketone supplements as well on health. I found Jonathan had a very balanced, nuanced approach to this. I learned a lot and really enjoyed it. And I think you will too, so stick around. Hi, Jonathan. How are you? Welcome to Inside Exercise.
Thanks for having me. It's a pleasure to be here.
Yeah, so keto diet. So as people would know if they've been watching my this podcast at all, they would know that I'm more of a carbohydrate man. That was my PhD was on carbohydrate availability and metabolism during exercise, and I do tend to lean that way a little bit. And I've actually seen a podcast you did with Kirsty Stocker. Do you know how to say her name? Kirsty
Chuck, I think.
Yes, another person from Canada. She is from Canada, right?
Yeah.
Yeah. And that was really interesting. And that was really good. I thought she did a great job. And you came across very balanced, right? So I guess some people might want, you to be a carbo man or a keto man, but I think you were a balanced man. Are you still a balanced man?
I am. Yeah, I'm the typical Canadian, I guess. I always say I'm diet agnostic. I don't think one diet's the best. I kind of stumbled into studying low carb and ketogenic diets. And I'm not a keto zealot, but I'm not a carb zealot. I think that different context and there's nuance in all of this, depending on if you're a person living with type 2 diabetes or an athlete or a Joe Blow who's training for their first 10K or marathon or something.
Wow, you sound like a scientist because you're open-minded. And you'll go with the data.
It's not very sexy when you're on Twitter or anything like that to be like that. But hopefully we can talk some evidence-based or evidence-informed science on keto diets today, and maybe we'll get to ketone supplements too.
Yeah. So when you said you stumbled into it, we'll get back to that later. But I actually know your name more from the high intensity, the HIIT training and things like that. Big. And the adherence to that, and
we're still doing a little bit of that. We've moved to doing the concept of exercise snacks. I know you've had Marty Gabala on the podcast before, and but still doing a little bit of work in that. But to be honest, the majority of my work right now is funded in more nutrition in type 2 diabetes.
Yeah, I mean, it's online or somewhere I saw your main focus: exercise, metabolism, type 2 diabetes, nutrition. That's right up my alley. But then the having the expertise in ketone, that's great as well. So now, what I often do starting out with people is just sort of wonder. You look like a bit of a lean man there, so I'm starting to think I might know the answer already. But whether you started off were you a sporty kind of person interested in exercise and then you got into research, or were you a researcher and then realized exercise is important and then started looking at that? How did you?
Yeah, the former. I was I played lots of different sports as a kid. I was a goalie in hockey, or ice hockey you would call it, but then I was a distance runner. And I ran cross country and middle distance track at university. I was actually at McMaster University, and I got into research. It was in actually a second year exercise physiology class with Professor Marty Gabala was the instructor, and I just fell in love with it. I can remember going to cross country practice one day and telling the guys on the team, I'm going to do a master's. This is so cool. I want to study exercise physiology, and kind of I was hooked from then, and went on and did a master's in sport nutrition at University of Saskatchewan. And then I came back and did a PhD with Marty at McMaster. That's where we did a lot of the HIIT work. And then did a postdoc kind of in immunometabolism, very basic immunology lab, creating type 2 diabetes in a cell culture dish, essentially.
Oh, okay.
And then kind of put that all together in my independent research program.
I think that's nice where you started off sort of very applied, or human, and then you went to different models and then you put them both together, which is kind of unusual. You see a lot of papers, people just cell culture, or they just animal work, and if you could mix things up, I think it helps to really try and get answers. Now, talking about cross country, you would probably know the World Cross Country was on in Bathurst.
Yes.
Yeah, I actually went up there. It was a classic.
Oh, cool.
I heard about it like 8 months ago. No, now make it clear, I went there to watch, because I've told people that, and I tell them, the Kenyans were there and the Ethiopians, and they said, so how'd you go? And I was like, no. Yeah, so I'd heard about it like 8 months earlier and then totally forgot about it. And I'm literally looking at Twitter the night before, and it says, well, gosh, I was like, oh crap, did I miss it? But I got up at 5 a.m, an 8-hour drive, and got there 1 minute before they started the mixed relay. Oh, it was awesome. It's just amazing. All right, so we're going to talk about keto diets and also keto supplements and exercise, but also with health. Yeah, so we'll sort of mention, I was trying to work out how we should do things and think, maybe should we talk about the health first and then the exercise performance? But I think we'll just mix and match to see how we go. Just it's just a bit of a chat. So are you happy if we just start off first with, I know you've done more on the supplements, but just, background on, what are keto diets, and what is the history, what's the rationale to it? And then we get into the supplements maybe.
Yeah. So, I guess it's called a keto or a ketogenic diet because your body is in endogenous ketosis, or producing ketones. And you produce ketones in your liver from free fatty acids. The history of the diet actually, probably goes back to 100 years ago or so as a treatment for epilepsy. So they noticed that fasting would help certain individuals with epilepsy, and then a ketogenic diet, when you keep carbohydrates very, very low and fats high, would induce ketosis, and also they showed that it would help individuals with epilepsy. And a medical ketogenic diet is actually still used for drug-resistant epilepsy now. So you can go to hospitals, and there'll be sometimes a nutritionist who specifically works with epilepsy in the ketogenic diet. That ketogenic diet that's used in epilepsy is not really the ketogenic diet that people are following, or the Twitter sphere is about, because that medical keto diet is usually about 90% fat, 9% protein, and 1% carbohydrate, because in that case, producing the ketones and feeding them to the brain seems to be the mechanism why it works for epilepsy. So you don't really want to ever risk going out of ketosis in that state. And a lot of those diets are supplemented with medium chain triglycerides, and we won't get into all that in order to sustain ketosis. The modern ketogenic diet is probably morphed from the Atkins diet, which was popular in the 80s, into what Jeff Volek and Steve Finney now would call a well-formulated ketogenic diet, and that's less than 10% carbohydrates. Usually that's 50, maybe 30, under 50 or under 30 grams of carbs a day. So quite low. Moderate protein, or normal protein, 15 to 20% calories coming from protein, and then the rest is made up of fat, so about 70% fat. So it's not as extreme as that kind of diet. And it's people. There's different ways to follow that ketogenic diet, right? So lots of people think of it as butter and cheese and ribeye steaks or something like that. But I think you can also eat a ketogenic diet that has lots of leafy green vegetables, non-starchy vegetables, cauliflower, broccoli, eggplant, or you would call it aubergine, I think, in down under. You can have moderate amount of nuts, very small amount of berries, and then you have your meat or your eggs, and then you top it up to taste with a fat or an oil. So that diet, I think, is a little bit different. Some of the knocks on the traditional ketogenic diet are based more on the research from that medical epilepsy. You can eat, plenty of fiber and micronutrients and vitamins on a well-formulated ketogenic diet. The key is low carbohydrates, low insulin will lead to high rates of lipolysis. Those fatty acids go to the liver converts them to ketones. Beta hydroxybutyrate and acetoacetate are the two, so that's the ketogenic part. Those ketones are released from the liver and provide an alternative fuel source, primarily for the brain, but also other tissues. Your heart and your skeletal muscle can use ketones to a small amount. And which is even cooler, and what we're more interested in is the role of those ketones, particularly beta hydroxybutyrate, as a signaling molecule. There's now tons of cool, exciting data coming out that beta hydroxybutyrate acts like a hormone, can interact with certain receptors, trigger different signaling pathways. Beta hydroxybutyrate can itself modify proteins and cause post-translational modifications to proteins and alter gene expression. So there's lots of cool new research on beta hydroxybutyrate as a signaling molecule in addition to
Okay. All right. So there's quite a lot of stuff there, which is interesting. I might just unpack a little bit of it.
Sure.
So basically you're saying, that when you're on a high fat diet, yes, a very high fat diet, you will get more fatty acids in the blood. They will go to the liver. Whoop. Did I say something? You went to say
I think it's more the low carb, I think, because you need that low carb, low insulin.
Oh, the low insulin, of course.
Facilitate, right? Because when you eat fat, it doesn't necessarily mean your fatty acids are high, right? It needs to come from a lipolysis. So the insulin's got to be low.
Beautiful. All right. So let me do my summary again. I could see I'd gotten wrong already. Okay. So when you have a low carb diet, yes, and you're obviously talking about with these diets, it's a high fat, whether it's not as high as the 90% you were saying for epilepsy, but maybe 70, 80, is that what you said? 70?
Yeah.
Yep. Then you have because of the low insulin, because when you have carbohydrate, you have insulin released from the pancreas that stimulates glucose uptake, etc. You don't need that if you're having a low carb diet. Then your body's naturally going to favor using fat, and you're going to have fatty acids being released from the, you're going to have ketone bodies released from the liver. Right. Now, what I want to do there, okay, and then I want to just talk a little bit about what these ketone bodies are without being too complicated. Sure. And a big one of those you said is beta hydroxybutyrate, and that can have other effects as well. Yes. So you said it can act as a hormone, etc. So just to say there, what are these ketones? So they're shorter. So maybe just say what a fatty acid is, 16 carbons, 18 carbons sort of thing, and what a ketone body is. And maybe why, even why maybe you think the body starts pumping those out.
Yeah. So they're hydrocarbon molecules or weak acids. They're produced from, when you take a fatty acid, palmitate has 16 carbons. Your liver, when it's breaking that down, is going to chunk it out into 2-carbon acetyl-CoA units. Yes. And then you can take that 2-carbon acetyl-CoA unit, combine two together through pathways, which we don't need to get into, make acetoacetate, 4 carbons, process that into beta hydroxybutyrate, and gets released. Beta hydroxybutyrate is very similar to lactate. And it actually seems to be the ketones are transported through the same transporters, MCT transporters, as lactate.
I did not know that. Hang on. So lactate is so for people, a lot of people know lactate, and that's coming from carbohydrates. So, glucose and glycogen is the stored form. Glucose is what's taken up. 6 carbons. It gets broken down to 3 carbons. So lactate is 3 carbons. How many carbons is beta hydroxybutyrate?
4 carbons. So acetoacetate and beta hydroxybutyrate, 4 carbons. But you're right, same transporters.
That's interesting.
For transporting
Because I
free
thought
carbon lactating or carbon
the
ketone.
transport would be smarter than that. So this is these MCTs, so monocarboxylate. Hang on, you tell me. MCT, monocarboxylate transporter 1 and 4 are the ones that are taking lactate in and then out again. But they also take up ketone bodies. That's amazing. Okay. So does that mean, therefore, well, probably a bit ahead of ourselves, but if you're exercising at a high intensity, you could be having them take, you could have lactate and, well, let's get back to that later. Let's get back to that later, because that's more supplements. Yeah. All right. So we'll try and just focus on the keto diet, and then we'll talk about the supplements, although I'm obviously myself here a bit. All right. So you said there's basically different types. Yeah. So the kind of extreme, I couldn't help thinking, because it seems like on Twitter anyway, everyone wants to be in ketosis, let's, have your little ketone dipstick and make sure you're in ketosis. Well, if they want to be in ketosis, why don't they go all out and say, let's go 90%,
Yeah, I think, one would be, it's really hard to stick to that, that diet, a knock against keto diets. I think you could make it a knock against any diet, which is restricting something, is that over the long term, people tend not to stick to most types of diets. But I think it's just, a little bit, it's easier to stick to. And again, in the modern ketogenic diet, I think you can eat what's a relatively normal meal, a salad with some vegetables and a protein source and homemade or a low sugar, no sugar salad dressing on there. And it's a little bit normal. Whereas if you're going full out, the epilepsy ketogenic diet, it's often supplemented with, meal replacement shakes that have high fat in them, essentially, right? So not very pleasant or enjoyable to eat.
Okay. And I always just keep thinking, for me, like a normal, healthy, mixed diet is not that hard to stick to. Although, okay, fair enough. I was just thinking, I do tend to eat a lot of chocolate, but does that tell us anything? The fact that it's actually hard to stick to something that's a keto, does that tell you that
so
maybe?
I think so certainly it is, right? That the data would bear that out in randomized control trials. When you go longer than 3 or 6 months, people tend to stop adhering to a low carb or a ketogenic diet at the mean level, right? So you do an intention to treat analysis, and 50% of the people might still be following the diet.
And why do they? Why do they stop?
Yeah, I think again, I don't think that's that specific to a low carb diet. I think people don't adhere to a low fat diet.
They're not stopping because they feel crap and they don't have energy. It's just more that they're not sticking to a diet, just like people don't stick to. I just said I don't stick as well as I should. I've got a vegetarian wife and we eat very healthily, but I've been known to eat a family block of chocolate a day. It's just ridiculous. Right. So I think I'm a little case study there.
And again, there aren't RCTs with adherence as the outcome, right? But if a good example, we ran a study comparing keto diets using an app and the Weight Watchers diet, which is kind of a low fat calorie counting type of diet using an app. And after 12 weeks, twice as much weight loss with the ketogenic diet. But then after 6 and 12 months, both groups drift back up, and there ends up being no difference at the end of the 12 months. Right. And it's because, there's, again, 30 or 40% of the people are sticking to the ketogenic diet in the ketogenic group, but the others aren't. Your mean weight loss ends up.
You can't blame the keto diets, because the keto diet actually worked for the weight loss, but they didn't stick to it.
And again, I think maybe it's a little bit harder to stick to a ketogenic diet, but I think it's hard to stick to any diet, and people probably pick a little bit from each diet that they continue to stick to, and then they go back to other ways, or there's so many socioeconomic pressures coming around diet, right? But I think of it as the same way as exercise. People don't adhere to exercise.
Exactly.
The trials show at 6 months, 50% of people are doing no exercise after an intervention, but we still promote exercise and say that exercise is good. We don't say, oh, we might as well give up on exercise because people can't adhere to it. So again, and that's, I'm not being a keto zealot there. I think that's just, I don't think that's a fair critique of a ketogenic or low carb diet.
So just actually, just after you mentioned that about the weight loss on a keto diet, what is the mechanisms there? So I know that there's quite a bit of talk about high protein, having a satiety effect and eating less food and losing weight. What's the mechanisms there? And I know that quite often people are having quite a lot of protein on keto diets as well. What are the mechanisms there where it does seem to work?
Yeah, there's a little bit of talk about a quote unquote metabolic advantage on a low carb or ketogenic diet. So when you lose weight, your body is smart. It's trying to hold on to weight. So your basal metabolic rate is reduced. And there's, one large study that has some critique, and there was a, Twitter war about it, that maybe your metabolic rate doesn't reset as low when you're on a low carb compared to just a regular calorie restricted diet. All that aside, to cut to the chase, the reason a ketogenic diet works for weight loss is you reduce calories, right? And it's just a easy way for some people, or a trick. If you're cutting out carbohydrates, right, and you're keeping that to less than 10%, there's not a lot of food that you can eat when you're out and about. Think about going to a cafe, going to a restaurant, go to the office party or whatever. If you're sticking to
fat and carbs, it's fat and carbs everywhere.
It's all, either carbs or carbs with fat. So the eating opportunities, and I think that's one way that a ketogenic or a low carb diet might be good for a lot of people. You cut out a bunch of junk type foods, right? You can't eat cakes, pastries, breaded, deep fried things, chips, crisps, French fries. If you're going to stick to it, you don't eat those things. So your eating opportunities are down. Now, that being said, that's probably not the only thing. A lot of people on low carb or keto and lower sugar, they tend to say that they don't have as many cravings, or they don't feel as hungry. Again, hunger and satiety, I'm not an expert in that. It's obviously more complicated. There's maybe some evidence that ketones themselves, if you're in ketosis, might reduce hunger or have less cravings. And then maybe when your blood sugar is stable and your insulin is low, that may also play a role. But I think 70% of the benefits are just you're cutting out
less opportunities. Food, right? Okay, so I know some people are going to be thinking about this evil carbohydrate, evil sort of glucose spikes, excursions, etc. I don't know what you think about this, but I tend to think if you're a person with type 2 diabetes, then sure, having glucose going up and down is maybe not ideal. But surely if you're a lean chap like you who exercises, or even if you don't exercise, but if you have normal glucose tolerance, normal insulin sensitivity, I tend to think that glucose going up is just normal response to eating food. Although, to be fair though, to eating normal food, not just drinking cans of Coke, but eating food with carbohydrate, it's normal for the glucose to be, the carbohydrate to be broken down, glucose absorbed in the blood. That causes, the pancreas to release insulin, and that brings it down. And this is not evil at work.
I completely agree. That to me, that's normal physiology. If you eat a bowl of pasta and your glucose goes from 5 millimoles to 7 millimoles, and an hour and a half later, it's back down to close to normal, I think that's a normal physiological response. And probably, there is data on, for your insulin sensitivity, eating carbohydrate. If you're insulin sensitive and you eat carbohydrates, it actually makes you more insulin sensitive, right? So, but I think that's your point at the start. That's one reason why low carb or keto would be beneficial for someone with type 2 diabetes. It makes complete sense, right? You're intolerant to carbohydrates, don't eat them, or limit your consumption of them. You don't get these big glucose spikes, which cause oxidative stress, inflammation, platelet activation, endothelial dysfunction. So you're stabilizing your glucose. That could be good. The question then becomes, obviously, what are you replacing the carbohydrates with? Which is why nutrition is so tricky, right? To cut out one thing, you're going to replace it with something else. And that's where it gets, more nuanced and complicated.
Yes. All right. So I guess the thought there is, what does happen to your other, so, if you're a person with type 2 diabetes, or even if you're not, just having these low carbohydrate diets that tend to be higher in fat, what effect does that have on your cardiovascular risk, your risk of diabetes, your HDL, LDL, all that sort of stuff?
Yeah, great question. So I think everything needs to be balanced, and it depends on the person and the situation, right? So certainly we've done a meta-analysis on this, others have. When you're on a low carb, high fat or ketogenic diet, on average, LDL cholesterol, total LDL cholesterol concentration tends to go up. But so does HDL. So, maybe you balance out. And again, I'm not a cardiologist. We've looked at the LDL particle size. So the thinking there, right, is that LDL concentration is not the whole story. If you have large, fluffy LDL, that's good. If you have small, dense LDL, that's bad. The data is not super clear. Again, we had a meta-analysis on this, which tends to suggest, I think, that low carb diets increase the particle diameter size. So you tend to get increased LDL, but it is of the larger, more buoyant LDL, which would be less bad. But that's not always the case. So it's a bit nuanced there, but I don't think it's as simple as, okay, because you ate high fat, therefore it's damaging to your arteries, or therefore you have increased risk. It probably depends on the type of fat, the food matrix that you're eating that in, et cetera, et cetera. Overall, though, if I could summarize that up, it's not necessarily 100% bad or 100% good. And we would always say, and I think even the proponents of ketogenic diets that are also scientists or physicians, you should, or dietitians, you should monitor your blood lipids when you go on one of these diets to see if your LDL, some people's LDL cholesterol seems to go up really, really high, and that's probably not a good thing. And that person may not want to do that. But in someone with type 2 diabetes, which is primarily what I study, typically your A1C goes down, you lose weight, you're not having those glucose spikes, your fasting triglycerides go down, your waist circumference goes down. So you get, 6 cardiovascular risk factors get better, one gets worse. What would you do in there? Personally, if I had type 2 diabetes, I'd take the 6 wins for the one loss there. Maybe I go on a statin or something like that to try to balance that out. So I think that just focusing on one parameter is probably not the best.
Well, so I was thinking about that as I was talking about it, because you were saying, the LDL does this and that. It can tend to go up. But I was thinking, well, hang on, you'd already said earlier that people tend to lose weight on it. So if they're actually sticking to it, they'd be getting the benefits. So it makes the comparisons difficult. I guess you've got covariance there, and
totally. And
like
again,
if you're trying to work out
LDL going up, if you don't have type 2 diabetes, you said me, a lean, middle-aged male who is otherwise healthy, it probably doesn't make sense, in my opinion, to take that LDL hit for me to follow a ketogenic diet. I don't need to lose weight. I don't need to control my blood sugars. I don't have cravings or eat a lot of sugar or whatever. So I don't think I would, personally say, well, I'll let my LDL go up by 20 or 20%. Probably doesn't make sense. But again, like I said, if I had type 2 diabetes, I'd be thinking about it. If I went on the diet and it worked for my blood sugars and my body weight and I felt good, I might take that LDL hit for the other benefits.
This is how things get nuanced. And this is why I know we're giving Twitter a bit of a hard time, but this is why it's hard. If you don't have a bit of a background and you haven't looked into it enough, you can just take this, here's a tweet, you should go on a keto diet because it improves diabetes and whatever. It's like, I don't want to get diabetes. So, you might be lean already. You know what I mean?
Yeah, I think that the diet that's the best for someone living with type 2 diabetes is not the best, might not be the best diet for preventing type 2 diabetes. And that's where I think the low carb and the keto has gone a bit too far, particularly on that social media, right? Like because somebody got their type 2 diabetes into remission on a ketogenic diet, you know, therefore carbs are evil, don't eat them and you won't develop type 2 diabetes. That's a bit tricky, right? That would be, I don't know, what's an analogy from medicine? Like, someone with type 2 diabetes goes on metformin and an SGLT2 inhibitor, you know, therefore everyone should take metformin and an SGLT2 inhibitor.
Well, it is actually quite interesting, because another example I was thinking of was blood pressure. Because you know how even if you're in the normal range, there's a bit of a thought, I think it's still the thought, that you still want to be at a lower level. So, you know, there is talk, people are talking about putting statins in the drinking water. So everyone gets it, you know. So let's not go there too much, I guess. But that's an example where you got to think about, you know, are your blood pressure, is your blood pressure high? Yes. Okay. Well, should you go on a statin, because there could be side effects, could affect your muscle function, etc. All right. So we've talked about. Oh yeah, I just want to ask about cheat days and taking breaks and things like that. Because I heard you say on the podcast with Kirsty, is it Christy? Christy, yeah. That cheat days may not be a good idea. So do you want to just talk about that?
Yeah, it's probably like one of the worst studies we've ever run by accident, but it got the most press, both good and bad, I guess. I think that lots in the keto community didn't like that study. It was you know, as you know, as these things go, I think it was the first study I ever ran as a PI, a summer undergrad student. We were essentially trying to pilot out a 7-day low carb, high fat keto diet to induce inflammation in healthy people. So that I was trying to set this model up, and like lots of things, the hypothesis goes the wrong way, right? So it was, let's pilot this out and see if we can induce inflammation, because all the animal studies and the cell culture studies I was working on in my postdoc, we would just treat cells with palmitate and it would induce inflammation, and then we study the mechanism.
Which is a fatty acid. Yeah.
Let's give people a high saturated fat diet for 1 week. And this is what we were thinking, we'll induce a bunch of inflammation, and then we can start testing all these different strategies to reduce inflammation. So we just did a single arm, 7-day, high saturated fat, low carb diet intervention. It didn't cause any inflammation. It actually lowered inflammation and lowered responses to inflammation, but we gave the individuals an OGTT before and after.
Oral glucose tolerance test.
Yeah. And again, probably a normal physiological response. You give healthy young people low carb, high fat for 7 days. They become a little bit glucose intolerant. So we had a higher blood sugar spike after 7 days. And that higher blood sugar spike led to more endothelial dysfunction. We measured flow-mediated dilation. You measure the ability of the blood vessels, your brachial artery, to dilate in response to blood flow, and that was impaired. And then we measured these circulating molecules, circulating extracellular vesicles, which are released from endothelial cells, thought to be kind of a marker that the endothelial cells are inflamed or angry. And those went up more during the blood glucose spike. So again, it was not it wasn't a randomized study. It was single arm. It was an undergrad student. We were pilot project kind of thing, but we didn't even think of it that way.
Yeah,
it got picked up in the media as the keto cheat day study, and all these people started talking about it. So it was kind of a funny coincidence that. So we thought about picking up on that after. I think we published the paper like 4 years after we ran the study, so it was like way in the long gone. We talked about, should we pick this back up and start to try to look at keto cheat days, but we haven't done anything since then. So
has anyone else done is there any other
I mean, other people have shown similar, if your glucose intolerance will be impaired or altered after low carb. And again, to me, that's not pathology. Maybe that's just, it's almost metabolic flexibility, right?
This is great, because I wanted to talk about this a little bit, and then it'll make more sense when we shortly start talking about exercise performance and things, because the body responds. I remember I did a prac in my undergrad, right? And it was, we got, I think it was rats, and we put them on a week of a high fat diet. And then we looked at all their liver enzymes. No, actually, I think it was just one day. It was one day of a high fat diet, looked at their liver enzymes, one day of a high carb diet and looked at their liver enzymes. So they totally switched. Now, I know things happen quicker in rodents. They have higher metabolic rates and things, but it makes sense that if you go on a high fat diet, your body will adapt to that high fat diet. And therefore, when you give it carbohydrate, it's going to be, well, what's this? And the same if you go on a high carb diet. So it's just, did you want to just flesh that out a little bit, that it's not surprising that, you know what I mean? Yeah.
Yeah, no, exactly that. I think if you took young, healthy, metabolically flexible, insulin sensitive people and put them on a low carbohydrate, high fat diet, and they didn't become more proficient fat burners and less proficient at metabolizing carbohydrate, that would probably be a bad thing, right?
Mm-hmm.
So I think exactly that. And I think David Ludwig has had a paper just came out recently about that carbohydrate or glucose intolerance when you're on a low carb versus a low fat diet and that sort of thing, that really more mechanistically teased that out, which I think the conclusion there was if you're going to use glucose tolerance, and they were doing continuous glucose monitoring as outcome measures, it takes quite a long time when you reintroduce carbohydrates in order to get your glucose tolerance kind of back to normal. So, and again, it just makes sense that is the way that you would metabolically respond.
If you ever do follow up that study, I think it'd be good to do, instead of an oral glucose tolerance test, which is 75 grams of glucose, which is totally non-physiological. No one's ever going to eat
Correct.
that. This, as you know, you said that's a few years ago, people have moved more a little bit to like a diet, just like a food test. So if you had a high carbohydrate meal test, I think that would be more interesting, because Michelle Keski here from Deakin University in Melbourne showed that if you have a oral glucose tolerance test, so just the straight glucose, it actually does not increase your capillary blood flow in the muscle, which helps to increase insulin sensitivity and glucose uptake. But if you have a mixed meal test, it does. So it's kind of like a strange physiological quirk, maybe.
Yeah. When we were talking about following that study up, what would the cheat day meal be? And it would be ice cream or pizza or something like that, not straight glucose or something healthy. It would be something that you would crave. So
and
for
something
me,
that you'd
bread,
actually
I would eat a whole loaf of bread if I was.
Oh yeah, I love bread as well. Okay, so let's starting to think about exercise here.
Yeah.
So again, without preempting things a little bit, I could see how things have started to go a little bit astray, where people go, oh, okay, we know, burning fat's really good. Endurance trained people get better at burning fat, sparing their glycogen, sparing their carbohydrate, and they do really well. Therefore, Do you want to just talk about that? Why are people thinking about keto diets for exercise, and then what are the effects?
So, I'm not a performance physiologist. I think we've ran one performance study on ketone supplements in the last 10 years. And I know you've had Louise Burke on the podcast before. So, but I think the theory is that you have unlimited fat stores, essentially, right? And the top endurance athletes are prolific fat burners. So if you can make yourself even more prolific a fat burner, you can tap into these, virtually unlimited stores, not run out of your limited carbohydrate stores, and your endurance performance or capacity would be improved. And so that makes, a little bit of sense. But I don't think it's borne out in the vast majority of the literature. Louise's studies are certainly the best, with the best high caliber athletes and the best control. And they show what I learned in Marty Gabala's second year exercise physiology class, that fat wins on kilocalories per gram, fat wins on ATP per carbon, but fat loses on ATP per oxygen, and it's oxygen delivery and consumption, which is going to be limiting during endurance performance at that elite level. So your ATP per oxygen is better on carbs versus fat. So if you force the muscle to use fat, efficiency drops, and therefore the oxygen cost at the same speed is higher. Therefore, that's higher percent of your relative VO2 max, and you don't perform as well. So it kind of, it makes sense on the unlimited fat stores, but then when you dive into the actual metabolism, it doesn't. For the vast majority of sports, right? Of endurance sports. Maybe when you get up to ultra endurance, or if you're doing a 24-hour race or something like that, that's where maybe I think the ketogenic or the low carb might be beneficial. And even then, I don't know if would be completely because of the unlimited fat stores. It's probably that if you can push your fat oxidation that high, you probably don't need to rely so much on exogenous carbohydrates, and then you have less GI distress and all those things which tend to affect the 12 or 24-hour races of people. So that's where I would be at. If you're an elite athlete, unless you're ultra endurance, it's probably or not really going to be in your best interest to be on a keto diet.
Yeah, so just to unpack that a little bit there. So as you said, fat is great so ATP is, your most immediate energy source for contraction, et cetera, in the muscle. So, you're eating carbohydrate, fats, et cetera, they get stored or they get taken up in the muscle, they get broken down, and the ATP is what you're getting. So you're saying that, fat is the best for storage because you get, you've got the most ATP per carbon that you get. So when you store it, also you don't have to store it with water. So glycogen, you need to store with water. Fat's hydrophobic, so it doesn't have water. So you can pack it in, as we know, a lot of us know too much. It's great to store it. A lot of energy per carbon, so per unit of storage, and you're getting more ATP per carbon as well. Okay, but as you say, you need to use more oxygen per ATP, right? Which is fine if we're sitting here at rest, and we tend to use fat sitting at rest. If you're going slow, that's fine. Oxygen's not limiting. But as it gets harder and harder, and you get up to the point where you're, sitting at kind of the highest percent of your VO2 max that you can hold, you'd like to get the most bang for your buck. And if you're using more oxygen, you can't go as quickly. So that's where using fat is going the wrong way. Is that a summation?
Yeah, that's exactly right. Yeah.
Now, one thing I'd like to add to that, I guess, is that you also you're not getting energy as quickly from fat. So if you're wanting to go faster, you use more and more carbohydrates. So did you want to just kind of flesh that out a little bit?
Yeah, and I think, for those that heard Louise's podcast, that they've shown that if you follow a low carb, high fat diet, even when you switch back for a day or two to high carb, you're essentially inhibiting carbohydrate metabolism or carbohydrate oxidation with that approach. So then you can't tap into that faster or fuel because of, again, to me, it's a normal metabolic adaptation that those athletes in those studies would do. They become good at burning fat and at the expense of burning carbohydrate, and then you can't oxidize carbohydrate to the same extent, and therefore your power output or ATP for O2 is going to be lower, and you're going to have to exercise at a lower rate or not be able to exercise at a higher rate for the same oxygen consumption.
Yeah, and I think that study, I would encourage people to go back and watch that great chat with Louise. Well, she was great. I'm not saying I was great, but anyway. Yeah, because the beautiful thing there that you touched on, I want to make sure people picked up on that, is that even when she put them on the low carb, high fat diet for 6 days, even when she put them on a day of high carb, right, and the glycogens went right up again, they still, and this is the one I think I wanted to make sure people are clear on, they burn more fat during the exercise after they've been on the high fat diet. So people go, oh, that's great. You'd look at that and say, that's great. And I was quite amazed when I first saw that, because sure, they're going to burn more fat when they've been on a high fat diet. That makes sense. And burn more carbohydrate when they're on a high carbohydrate diet. But even when they had the 1 day of high carbohydrate, put the glycogen back up, they were burning more fat, but they did not do as well. And that's the important thing. Now, what about people said with that study, oh, but that was only a week, but she's done longer, and she's done longer time trials, and it's equal or worse. It's never better.
Yeah, and exactly. And I think even all the data, even done by individuals that are proponents of ketogenic diets and that sort of thing, I'm not aware of any study where ketogenic diet turns out better for exercise performance, right? It's only sometimes equal, right? That would be, maybe you may be able to maintain your performance on a low carb, high fat diet. And that's, there's a couple studies came out from Andrew Kutnick and Lucas Cyprian recently, essentially that show over 30 days, and Lucas's studies are 12 weeks. You can maintain your endurance performance or your high intensity interval performance, Lucas's studies, on a low carb, high fat diet, but it doesn't show that it's better, right? It just says it's possible to do. And I think that's key. And again, as Louise would point out, those studies are done in trained athletes or recreational runners, but those aren't Olympic athletes like
Right.
what she was studying. So I don't think there's any real studies that would ever support that notion that if you can become a prolific fat burner and spare your glycogen, you will improve your performance. There's maybe a few saying, if you do this, you might be able to maintain your performance. If you're a recreational athlete to a trained athlete.
So obviously this can get controversial, yeah. So if I suddenly, another face came on, like they might have the initials TN, for example, what would that person say in response to that, do you think?
Yeah, I'm not exactly sure, but it's clearly, I don't think that going longer is, that's one of the criticisms of Louise studies is it's only 3 weeks long. The fat oxidation rates that they're getting and the metabolic adaptations, I don't know what else is going to change unless it's, epigenetics that happen after being on a low carb, high fat diet for 6 months. So, something changes and you're no longer inhibiting PDH or something like that. So I think that's the only kind of hand-waving response that you could get to say for elite endurance performance would be, we don't have a really well-designed study that's 1 year or 2 years long, but I don't think.
So how they had a recent study, I think they got the fat. So people often are interested in maximum fat oxidation. So we know that it's probably, in an untrained person, it's probably like 40% of VO2 max or something. And then a well-trained person, it'll get up to like 80, 85. I might have the numbers out wrong there. So they got people up to 85%, but they were not elite runners. Yeah, is it?
Yeah, I think the highest percentage that I can think of, I mean, I might be off by a couple percent, but I know Jeff Volek's done the study on ultra endurance runners who were on low carb, high fat for several months to several years. I think it's, in the 80 to 85% of VO2 max is where their fat max is. And their absolute rates of fat oxidation in that study are in the neighborhood of 1.5, 1.6 grams per minute. Which is pretty impressive. And I think that Andrew Kutnick's recent study,
that one.
They reported, I think they call it the highest ever reported at 1.8 or something grams per minute maximal fat oxidation. So those are really impressive, numbers, no doubt. And again, there's Andrew's study that's from 30 days, right? So you're able to push people up to that level with 30 days of low carb, high fat. I don't think it's going to get any more after 60 days or 90 days or 120 days, but I suppose we don't have all of those studies.
Part of the rationale we touched on earlier was if you burn a lot of fat, you're sparing this precious carbohydrate. Well, if the precious carbohydrate is so precious, why not just have high carbohydrate diets to increase your glycogen and then ingest carbohydrate during exercise? Why not do it that way instead?
Yeah. So, I mean, I think, it gets complicated. There's no simple answer, but one way and one argument I've heard is that if you have to ingest that many carbohydrates before, during exercise, you risk GI issues. So I think, again, the elite athletes are probably dialed in and training their gut and all that sort of thing. A less elite athlete probably doesn't do as much of that, and then having too many carbs during their race or whatever might lead to GI issues. So that's where maybe a low carb approach might be.
What about these Kenyan distance runners? They seem pretty decent. They I've seen a couple of papers. They are eating like 75% carbohydrate. Could they run way under 2 hours if they're on a keto diet? Sorry, I'm being a bit silly here.
Yeah.
But, the best runners in the world choose high carbohydrate diets on average.
Yeah, and I think so. I guess if you go back to that, to your thing before, if a different face came on, and I think where maybe Andrew Kutnick's recent work is going is that maybe the high carb is going to lead to health impacts later on down the road. So if you're always focused on carbohydrates, drinking sports drinks and gels and trying to pack as much as you can in, maybe that helps your performance now, but it has health effects down the road. And I don't think we know the answer to that, but I think probably rightly so. If you're not an elite athlete, you probably don't need to be packing in the gels and sports drinks and things like that. Regular food is probably pretty good for you.
Again, so yes, because again, even though I've had people on that have been mainly focused on carbohydrate and endurance over and over. So Mark Hargraves, a couple of others, Javier Gonzalez, saying, you don't, for many people, you don't need to be having carbohydrate. And I even use the example, before, during, after, like every millisecond carbohydrate. I used an example of a participant I had. He was getting 25% of his energy needs per day were coming from carbohydrate drinks, And I during my PhD, I actually wrote a study, and it was wrote an article for the university newsletter, and it was labeled "Carbohydrate Drinks Fail the Fitness Test," which wasn't my the editor stuck that on there. But my whole point was that most people do not need carbohydrate drinks. They can just have normal food, and even for glycogen resynthesis, you don't have to pack it in. As soon as you finish, after 24 hours, it's going to be pretty much normal. You don't have to have it straight away and masses of amounts. But again, if you're a very serious endurance athlete training twice a day, then maybe. But I just want to make sure people are clear here that we're not saying everyone should be going nuts on carbohydrate. And that was a takeaway from Mark Hargrave's chat as well. So it's things in moderation, and actually doing what you metabolically need. If you want to do something really fast, then you would have to think about carbohydrate. If you're doing something slower and longer, then you can afford to burn more fat.
Yeah, and one point, I don't know if this will come out, but just as we're on this topic, I think where low carb, high fat, or ketogenic diets and athletic performance might have the biggest bang for the buck is in the recreational athlete who is living with overweight or obesity, and losing 10 or 15 pounds will help that individual run faster or cycle faster or do their triathlon faster. And if a shorter term, 3 to 6 months or 1 year low carb, high fat diet can help that individual lose 10 or 15 pounds, then they're carrying around less body fat. They'll probably improve their performance.
Exactly.
It might not be because they're
the
better fat burner now. It's because they've lost the weight. But I do think that that's maybe a legitimate consideration or use where LCHF or keto might be of benefit. But I don't think it's because of the fat burning, glycogen sparing in that situation. It's because of the body composition changes.
Actually, I know we need to move on, and I'm keen to move on to ketone supplements. Just a couple of questions here from Twitter. I think we sort of half touched on this one. Mark Preben Lindbach sent a few really good questions, actually. Adherence to a keto diets may improve glucose tolerance measured via HbA1c and fasting plasma glucose, but not via OGTT. So you mentioned that already, oral glucose tolerance test. But does keto dietary pattern translate into decreased risk of diabetes-related complications, i.e. micro and macrovascular? So maybe just talk a bit, because I guess we didn't talk about that, keto diets and glucose tolerance more long-term if you look at the HbA1c.
The short answer to that is we don't have that data, and we definitely don't have that data from randomized controlled trials, long-term hard outcomes like cardiovascular or microvascular, macrovascular events. This is where you have to extrapolate, right? So that's where you would say, well, if you adhere to it and your A1C drops from 8 to 7, that would be expected to lower your risk by this much, but your LDL cholesterol might go up by this much. And I'm sure there's people, I'm not an epidemiologist or statistician that could run some models like that to try to figure out if, with a bunch of assumptions that would have the effect. But I think that would be the only way that you could do that. I don't think there's going to be hard outcome studies. The only one that might be able to tell us that is the Virta Health study. So Virta Health is a tech company which Jeff Volek and Steve Finney are involved with, delivering a ketogenic diet for what they call type 2 diabetes reversal. So to treat type 2 diabetes through a telehealth virtual medicine type of program that promotes a ketogenic diet. And I believe they have 5-year outcome data on that, the N of about 250 in the treatment group. And they're planning on following it up. So they may be able to give us a little bit of a signal there with long-term outcome data, people with type 2 diabetes, but it will be a non-randomized study that's, obviously funded by a commercial entity with some skin in the game. So there'll be some caveats to that data. But other than that, we have to lean on epidemiological data to try to sort that out. And I don't think you can make much sense of low carb and ketogenic diets and epi data.
Actually, another question, which is one we hadn't really, or I hadn't thought about, was this one here. So Hiko Grimi, I think, how much carbohydrates per hour might be enough for a keto adapted athlete during a long distance triathlon? 25 grams as Tim Noakes once estimated, ? So I guess we've been sort of talking about, if you're keto adapted, you can use maybe up to 85%. You could burn fat at 80 to 85% of VO2 max. But is the idea then that they would then be ingesting carbohydrate during the exercise, just like someone who's carbohydrate adapted?
Yeah, so I think the elite ultra endurance athletes and that sort of thing probably would be, right? They're probably also consuming carbohydrates, but maybe not at the same rate. I don't know the answer to that, but I thought it would be a really good question for my 3rd year exercise metabolism class, because my thought there is we could figure that out, right? You could say what's their RER, what percentage are they of VO2 max are they running at? We could use some of Javier Gonzalez's estimates on gluconeogenesis, and the exogenous carbohydrates are supplementing the liver glucose output, and we could do some assumptions there based on metabolic rates and carbohydrate.
I guess if you maintain your glucose, sure. If you,
I
guess your glucose is dropping.
I'm trying to think of, the data from Andrew Kutnick's recent study and Volek's study, though I think, again, I'm around 1 gram per minute of carbs they're burning in those, keto or low carb when they're doing an endurance run. So, you're getting some from gluconeogenesis, and you got to supplement that. 25 grams probably seems seems reasonable there, I think, but I'm not sure.
Well, it's interesting you mentioned RER there. So there's a question, John Dyer. What about respiratory quotient on keto? This is a thing. It's really a respiratory RER, respiratory exchange ratio, because respiratory quotient is where you measure it across the organ. But anyway, what about RER on keto? Some people appear to have crazy RER values and do 100-mile fasted bike rides with ease. Suspect they have a genetically RER that allows this. or do you really just have to train? Okay. So yeah, I've seen these people talking about doing, 100-mile bike races faster than things, which with ease, which, hats off to them. I would not fancy that. 100-mile bike race is hard enough already. Doing it fasted. Anyway, but the point there is that obviously they get quite low RERs, I guess, because they're burning a lot of fat.
Yeah, and that definitely yes. And I'm trying to think of, we've had one, I can remember testing one guy on a VO2 max test who is a long-term keto diet guy, and certainly, his RER was crazy low, and his RER at VO2 max was, barely above 1,
really?
which I guess
Wow.
would suggest that he's not able to
Exactly
tap into his carbohydrate oxidation, because his PDK is so high that is inhibiting PDH, and but so it's impressive from that perspective, but then again, it goes back to what would be the.
Well, that's interesting. So just you've mentioned PDH a couple of times, so I might just make sure people are clear on that. So basically, when you're breaking down carbohydrates, so just say from glucose, it gets down through glycolysis to pyruvate, and it can go to lactate, and that would be anaerobic, or it can enter the mitochondria. So PDH converts pyruvate to acetyl-CoA. Now you're in the mitochondria, it's going to be aerobic metabolism. And what you're saying there is that when you're in ketosis, you may be inhibiting this movement from pyruvate into the mitochondria, so you're blocking your carbohydrate breakdown. Is that right?
Exactly. Yeah, that data we talked earlier from Trent Sullenworth and Louise Burke was the high fat diet leads. So PDH is regulated covalently. When it's phosphorylated, it's turned off, and the high fat diet seems to increase the phosphorylation of PDH, so it's more turned off, less turned on. So pyruvate can't get in.
It's very interesting, because it ends up the pyruvate goes to acetyl-CoA, and that's where fat enters as well. So it's a bit beautifully sort of designed that if you've got your acetyl-CoA coming from fat, then you'll tend to have less from carbohydrate. And you're saying in that VO2 max test you did, it looked like they'd turned off their PDH. They'd stopped the carbohydrate getting to the mitochondria to such a point that the RER barely went up above 1. And that's remarkable. I've never seen that. So that's crazy, because the whole point, I know we're getting a bit, but the whole point is you start to produce a lot of lactic acid, you start to hyperventilate, you blow off carbon dioxide, your RER goes above 1, and they're actually stopping all that, which is pretty amazing.
Yeah, I think we brought the guy back in and redid the test because we thought the cart might have been wrong, and it happened again. So, but it might be an extreme case.
Wow. Okay. Well, that's kind of blown me away slightly. Which is good. I like that. Okay, so ketone supplements. So now we're finally getting to what you've done a bit more on. So this is really interesting. And I have to admit, I haven't really seen much of this literature. I've seen it talked about. So why don't you just explain how that's quite a different dynamic altogether? So you're on a normal mixed diet, for example. You could even be on a high carbohydrate diet, and then you take ketone supplements.
Exactly.
And why would you do that?
Yeah. So these ketone supplements are the majority of them are beta hydroxybutyrate. So that one specific ketone, either bound to a salt or a mineral. So ketone salt, ketone with sodium or magnesium or calcium, or there's what the more potent and probably the more used is called a ketone monoester. It's ketone with an ester bond to a molecule called 1,3-butanediol. So 2 molecules bound together in your gut. It cleaves that bond, you release beta hydroxybutyrate directly into the blood. The 1,3-butanediol goes to the liver and is actually converted to beta hydroxybutyrate. So you get kind of an immediate response and then this more delayed ketogenic response. So you take a drink essentially, and within 15 minutes, your ketones are up. Obviously, depending on how much you take, it depends how high they go, but you can get ketones up to 3 or 4 millimoles with a 30 to 50 gram dose of these ketone monoesters. So that's, to put that in context, that's equivalent to, nobody gets that high on a ketogenic diet. That's equivalent to fasting for 5 days or something like that, the level of ketosis you would get. So it's a really unique situation for the body because you have these ketones floating around, but you haven't starved yourself or been on a ketogenic diet.
And you're not fat adapted. I guess you're not fat adapted either.
So the theory, or I think the main theory, is what would be that they provide an additional fuel, right? I've seen them called the 4th macronutrient, right? You used to not be able to consume ketones, you'd only produce them. Now you can drink them. So the theory was that they could replace the other fuels, primarily fat or carbohydrate, or provide an additional fuel, similar to the concept of the keto diet. Additional fuel, spare muscle glycogen, and then you could, exercise longer, exercise harder. So there was a paper that came out in Cell Metabolism in 2016, which showed that this ketone drink before exercise improved time trial performance. They did some fancy metabolomics on muscle biopsy samples, some assumptions based on blood samples and beta hydroxybutyrate levels to suggest that the beta hydroxybutyrate was being used by the muscle, was sparing muscle glycogen, and that was the mechanism. Since then, there's maybe 20 performance papers. Nobody's been able to replicate the performance enhancing improvement since then. Maybe one paper with multiple outcomes and rugby players doing repeated sprints maybe has a bit of a signal, but by and large, it doesn't improve performance other than that one paper. There's a lot of nuance and context there. Do you take the ketones with carbohydrates or without carbohydrates? What dosing strategy should you use, etc.? But I think bottom line would be, I don't think the ketones are enhancing performance. There's only one study that shows that. I know now that they're still being used, and the thought is they're being used primarily in recovery because beta hydroxybutyrate naturally goes up at the end of long duration exercise, right? And there's some evidence that beta hydroxybutyrate or ketosis might prevent protein breakdown, increase protein synthesis, increase glycogen resynthesis. And then, as I mentioned at the start, ketones have all of these cool signaling properties: anti-inflammatory, antioxidant, histone deacetylase inhibitors that might affect the adaptive process. So I think now that the field, if we could summarize it, would be introduced as an alternative fuel to boost performance. Very likely that's not the case, but now maybe some of these recovery performance or recovery for the next day's performance or adaptation over time is where the field is going.
That's interesting. All right. So there's a lot of interesting stuff there. I just want to step back a little bit. So what was the time trial in that original paper?
Again, I think it was a 20-kilometer time trial after a 1 hour preload.
1 hour like submax, and then
1 hour submax.
Okay.
Typical design.
Right. Yes.
You would know, but for the listeners, you do a set amount of work so you can measure metabolism, and then you have the athletes or the participants do a time trial, which obviously is a good study design, but that's not how athletes actually race all the time. Although I guess some races are kind of like that. You're in the peloton and then you would have a breakaway at the end. So maybe it is relevant to some cycling race.
So did they compare that to carbohydrate?
Yeah, it was that study. Again, all the studies are a little bit different. In that study, it was carbohydrate versus ketone plus carbohydrate, which was a benefit of that study.
Sorry, carbohydrate ingestion, during the submax and during the performance, right? The time trial?
Again, I think it was before the submax, and then I can't remember. There was like 3 studies in one in that, so I can't remember if they gave it a dose later on.
So that's, I guess, what I'd be interested in if people were, but you're saying on average people aren't finding this performance effect anyway, but I guess I'm just thinking that would be the best sort of comparison to have carbohydrate drinks versus. Yeah,
exactly. And there's been a few, so like Peter Hespel's lab, Kjell Poff, and Brendan Egan has done some work with, we've done one study in collaboration with Marty Gabala. Devin McCarthy's PhD student just defended his thesis last week. Actually, I was there. And trying to do optimal sport nutrition guidelines. So carb loaded, carbohydrate meal, carbohydrate supplementation, and then add ketones on. And in those situations, it's never been shown to improve performance.
Okay. And what about if you do keto diet and then keto supplements?
Yeah, so Louise actually has done the best study on that in the race walkers. So they had one of their supernova studies, 3-week keto diet, and then with ketone supplements. And it didn't didn't improve performance, and it didn't negate the performance decrement or the lack of performance improvement in those studies. And this is random aside, but I think this is relevant. It makes no sense to me to be on a ketogenic diet and take ketone supplements, because the ketones themselves inhibit lipolysis.
Okay, so which is breaking down fat, yes.
So directly they bind to the HCAR2 or the GP109A receptor on adipocytes and inhibit lipolysis directly. The beta hydroxybutyrate does. So if you're on a ketogenic diet, you want lipolysis to be high for your liver to make ketones. Taking extra ketones exogenously will inhibit that process. And the exogenous ketones, we and others have shown that they give a little slight boost to insulin. So again, an insulin would inhibit lipolysis. So it kind of makes no sense to me, at least metabolically, to take ketones when you're on a ketogenic diet. Although I've heard companies or people say, if you're on a ketogenic diet, you're good at burning ketones, so therefore you'll be able to use them better. But I'm unaware of any evidence for that, and it doesn't make sense to me.
Okay, just to make sure people are clear on that. So some of these terms, lipolysis and things. So lipolysis is breaking down. So fats are also called lipids. So we're talking about lipolysis, breaking down lipids or fats from the adipose tissue, so your fat stores, because there is also fat and muscle, but we're talking about the love handles and things. So releasing the fat from the fat stores, so it can go to the liver and produce ketone bodies. And you'll say the ketones themselves, ketone bodies, inhibit that lipolysis. So you're going to, you're fighting what you actually want, which is more fat going to the liver to produce ketone bodies. Okay, so that makes sense. All right. Okay, so it doesn't sound like ketone supplements are particularly, well, so far anyway, going to improve performance. What about health? I guess there's probably not a whole lot of effect on health, is there?
Yeah, well, there might be. So this is, we've been doing some work here. We noticed kind of serendipitously in the first ketone supplement performance study that we did, and others showed this too, that glucose was lower in the ketone conditions. Dove into the literature, and lo and behold, the classic work, infusing ketones lowers glucose. It seems to do this by lowering hepatic glucose production. So I know you've had Javi Gonzalez on before, and David Wasserman. In type 2 diabetes, what I'm interested in, the liver leaks out too much glucose, right? It's producing too much glucose, which is why you have high fasting glucose. Then the liver doesn't shut off properly, which is why you have high glucose after a meal. So we looked at this, we said, this is pretty interesting. Glucose is lower in a healthy person exercising when they have ketones. That must be a pretty powerful stimulus for reducing what we thought was liver glucose output. So we started studying the effects of ketones on glucose at rest, and then in response to an oral glucose tolerance test, that 75 grams of sugar. And we showed in healthy people, in people with overweight and obesity, that when you take the ketones as a preload or 15 to 30 minutes before an OGTT, you'd have a much lower glucose spike and improved glucose tolerance. So then we moved on logically to then study this in type 2 diabetes. And those are the studies that are going on in the lab right now, the impacts of ketone supplementation on glucose tolerance, free living glucose control, in people with type 2 diabetes, and we don't have any of that data yet to report, because those studies are still ongoing. But it makes sense. There's multiple mechanisms probably at play, but that reduced hepatic glucose production might be the main one, and that's the one that we think would make the most impact at lowering glucose. That being said, I don't think ketone supplements are going to be the cure for type 2 diabetes, or they're not going to lower glucose, the same as a low carb or a ketogenic diet, which we've studied. But we think that all of these other signaling effects of ketones, beta hydroxybutyrate in particular, might be really interesting. So that's what we're trying to follow up in conjunction with lowering glucose, if the beta hydroxybutyrate is also anti-inflammatory and also lowers oxidative stress. That would be an intriguing treatment or a therapeutic option for someone with type 2 diabetes, because you could get glucose lowering and reduce chronic inflammation, and maybe protect blood vessels from oxidative damage, all at the same time. So that's what we're trying to study in the lab right now. Very early days. People ask me, if I have type 2 diabetes, should I take a ketone supplement? I don't think so yet. We don't know enough for that, but it does seem to consistently lower blood glucose, which I think means it's having some signaling type effects.
Now, you were saying with the ketone supplements, you tend to take them before, so you're not exercise. You don't take them during as well, or?
So some of the studies in the exercise have done before and during. Again, and there's lots of nuance here. I think of some of the studies from Peter Hespel's lab where they have tried, let's give beta hydroxybutyrate or ketone supplements before, but then you want ketones to be coming down when you have to push at the end in the time trial or the final sprint of the race, because beta hydroxybutyrate would not be good at that point, and they've tried to play around.
Oh, you said
with
it
that.
inhibits the lipolysis.
Yeah, but again, I think in all the different ways that you slice it, the performance studies just don't seem to come out to improve performance.
Now, you mentioned just before about liver glucose output being elevated at rest in people with type 2 diabetes. So it fits with this question here from Twitter, Mitch Summit, I think. What is the relative importance of skeletal muscle versus liver for whole body glucose regulation, insulin sensitivities? This is one I'm interested. I tend to be a bit of a muscle sort of focused chappy, and I think maybe you're leaning more on the liver.
Yeah, so and I would say, as an exercise physiologist, my PhD's in skeletal muscle metabolism. I was a muscle focused person, but I think now for someone with type 2 diabetes, the liver and probably the beta cells are maybe more important than the muscle in overall regulation of blood glucose levels. So, we used to think fasting glucose is affected by liver glucose output, but the postprandial glucose is the muscle. But when you dive into the data, that's actually not really all that true. The failure in someone with type 2 diabetes, someone healthy person, yes, that's true. Someone with type 2 diabetes, that big blood sugar spike you get after a meal or an OGTT, the big reason is because you have a lack of a first phase insulin response and a failure to shut the liver off like you should. So then you've got glucose coming in from outside and the liver is still pushing it into the system. And that's why you get the big glucose spike. It's not because your muscle's not able to take it up. That's kind of later on in the postprandial period. So that's what I would say about that. In someone with type 2 diabetes, maybe the liver and the beta cell are a little bit more important than the muscle. And again, I'm interested, we didn't even talk about this, type 2 diabetes remission. We've got clinical trials going on in that right now. And to get type 2 diabetes into remission, you need to regain beta cell function and regain or lower liver glucose output. The muscle is kind of not as important in that scenario.
All right, so how about we start to wrap up time here? I know you're a bit tight, so you've got to finish up. So what I like to do sometimes at the end is to talk about takeaway messages. So what are two or three or four sort of takeaway messages you'd like people to take from this?
Sure. So one would be ketone supplements are not the same as a ketogenic diet. That would probably be a good one. And then maybe another takeaway would be, so a ketogenic diet likely does not optimize exercise performance. We talked a lot about that. And then my third one there might be, there's no best diet, but a low carb diet may be beneficial for some. So how are those for three?
Yeah, good. So I think they summarize everything very well, but would it be almost right to say, unless you're overweight, there's not much rationale for a keto diet?
I'd probably agree with that. Unless you live with overweight or obesity, pre-diabetes, type 2 diabetes, it probably doesn't benefit you to, I would put it that way. It probably doesn't benefit you to be on a ketogenic diet. I might
Actually,
not go as far as saying, it's useless, but I would say it probably doesn't benefit you.
Actually, I just remember something just to finish up from Kirsty's podcast with you. You said something about your normal lifestyle. You tend to, I don't know, skip breakfast, have a coffee. Correct me, obviously, if
So
I'm wrong.
I eat breakfast, but it's usually a low carb breakfast.
Yes. So why do you do this? And then you say you're normally in ketosis by the end of the day. Why do you actually do that if you're a lean chap?
So there's no real reason why. I eat a lower carb, high protein breakfast primarily because it makes I feel more full, and then I don't have to eat at lunch. And it usually is because I'm too busy. I don't have time to eat, and I don't really like lunch foods. I would like reheat leftovers. I would like for lunch, but I don't like leaving my office to go get lunch or bring a sandwich or anything. So it's kind of like I'm a very pragmatic person, I think. So I have this low carb, high protein, big breakfast, so that then I can just pretty much drink black coffee all day and don't get hungry. And then I have a lot of vegetables and a higher protein dinner. So I'm probably in a little bit of ketosis maybe at the end of the day, but not on purpose or for no real reason.
But the purposeful thing you do, which is again ties into what we're saying about if you're overweight, is to actually eat less. You're saying so that, but not because you want to lose weight necessarily, but so you don't have to stop working and have lunch. Is that right?
Yeah, pretty much. Yeah. Because I find if I have a typical Western breakfast food, if I have, a bagel with peanut butter or a bowl of cereal or something like that, I'm hungry at 10 o'clock in the morning and then I want to eat again. If I have a 3-egg omelet with cheese and spinach or something like that, I'm not hungry during the day. I maybe get a little hungry in the middle of the day, and then 1 or 2 coffees will kill the hunger for whatever reason, and I'm good to go. And
you're not, I'm figuring you're not worried about cholesterol or anything. So if would you do that if your cholesterol was a bit up, your LDL and all
that? I don't think eating cholesterol really affects your cholesterol. So
but the high fat.
Yeah, but I think an egg. I don't know if. I wouldn't. I mean, because I'm a metabolism nerd and because I have a lab, I'll test my cholesterol and my A1C and that every once in a while just to make sure everything.
Sorry, you just
good.
said an egg, did you? I was imagining you frying up bacon and eggs and all this.
Yeah,
stuff. No. Okay.
My wife, like your wife, is vegetarian, so we don't have any meat in our household, even though I would eat meat if I go out, but there's no meat in our house.
Exactly the same. My wife's a dietitian as well, so we're pretty tight. And then she brushes her teeth after dinner, so she won't eat any chocolate or anything after that. And I eat like a family block. Well, not every day, but okay. Well, thank you very much for coming on. It's been great, and I've actually learned a lot.
It was great, and I hope that people enjoy the podcast, and I look forward to listening to more of the guests you have on, because they're always great, and hopefully I can live up to even half of what what I learned from some of the other folks.
No, it was great. Thanks again. Okay, see you, mate.
Okay.
Bye-bye.
Thanks.
Bye. I hope you enjoyed this podcast. Please like, subscribe, pass it on to your friends and colleagues. Check out the other podcasts. Thanks again.